Now we can discuss on the nomenclature of a rock after the allocation of the different oxides to the norm. We have done already the distribution of different oxides including silica to in the norm rules. Now we have to find out which is the rock, that is nomenclature or naming of the rock. For that we can get there are some methods or some ratios which we have to describe to find out the name of the rock. First of all, we have grouped the weight constituents, weight percentage of different minerals based on norm calculation. Now we have got two main groups of minerals like salic groups and femic groups. Now we can determine the ratio of salic to femic from the rock which we have calculated. And after finding out the salic femic ratio, we can attribute the name of the rock according to the percentage of the salic femic ratio. For example, when the A and B is referring to salic and femic respectively. When the salic is extreme over femic, that means we can prefix per to A. That means if the ratio of the salic minerals are greater, then we can call that rock as persalic. Or when A is dominant over B, prefix do to A. That is dosalic. When A is approximately equal to B, there is no prefix or we are calling it as salfemic. When B is dominant over A, that is femic is greater than A, greater than salic, then we can call it as dofemic. B extreme over A means they are perfemic. And this ratio is determined by finding out we have got some values for the salic as well as the femic minerals. When we are determining the salic femic ratio, and if it is found that which is greater than 7, we can call it as a persalic rock. When the ratio is between 7 and 1.667, it is called dosalic. And 1.667 and 0.60 salfemic, and 0.60 and 0.143 it is dofemic. And it is called as perfemic when the ratio is less than 0.143. And there are certain constituents which are entering only in certain molecules. For example, I have told you that zircon dioxide is only forming in zircon, and P2O5 is going only to the formation of apatite. And other constituents are going to different molecules. For example, potash K2O is going to the formation of orthoclase, leucite or caliophyllite. And when you have to remember that the word amount is denoting the molecular number in the procedure. Now we can also determine the nature of crystallization or crystallization index from the values obtained, from the weight percentages obtained in the rock. The formula for finding out the crystallization index is albite plus 2 diopside plus 2.3 hyposthene. That is, after finding out the different weight percentages of different minerals, then if the rock is having albite, diopside and hyposthene, you can find out these percentages of albite with respect to these three minerals. That is, you calculate the percentages of albite from the amount of all the three only. Albite plus diopside plus hyposthene is taken as 100, and how much albite in this 100 represent, that is called albite percentage. Sometimes you may not be having diopside or sometimes you may not be having hyposthene. Then you can apply as per the equation, you can make changes. That is, this part will be there and the third part will be absent if hyposthene is absent. Then you can apply the percentage of albite plus 2 diopside percentage plus 2.3 hypocene percentage to find out the nature of crystallization or crystallization index. And if the value is greater than 123, we can say that pyroxene crystallizes first. And if it is less than 123, plagioclase crystallizes first. And if the value is exactly 123, the plagioclase and pyroxene crystallizes simultaneously. Then another thing which you can use while making the norm calculation is anorthite content of the rock. That is, your rock may be having both albite and anorthite, and in that you have to find out the anorthite content. That is, the anorthite percentage divided by the total content of anorthite plus albite into 100. Likewise, you can also find out the albite percentage. That is, the anorthite plus albite percentage will be making 100. Then another thing which is crucial in the naming of the rock is differentiation index. Differentiation index is computed simply as the sum of the weight percentage of normative quartz plus orthoclase plus albite plus nepheline plus leucite. That is, you are having different minerals which are present in the salic column, and they are taken except anorthite. So, these are the minerals which are taken into account for calculating the differentiation index, and you have to remember that always never more than 3 minerals will be present in a norm. If nepheline and leucite is present, you are sure there will not be any quartz. Or orthoclase and albite, if present, they will be present with the quartz. Then there will not be any nepheline and leucite. And the value which is got as differentiation index can be taken for granted while naming. For example, if there are some certain values which are given for certain rocks, that is, alkali granite is having 93, rhyolite 90, etc. So your rock is very nearer to a particular value, you can also look on the mineralogy, and it can be used based on the differentiation index value and the mineralogy. You can name that rock. That's all. Okay, thank you.